All right. Hello, everybody. This is Miss Pi again. I'm going to be going over page 24. I'm sorry, it is super late. I'm going over page 42, problems 10A, problem 11, problem 14, 16, and 17 in this video. And then when we come to class, we will do several problems on pages 43 and 44. So hopefully you brought your textbook with you. If you didn't, don't sweat it. Just write down, get a separate sheet of paper, write down the problems, and work your way through the problems with me. So far, we've been focusing on the explicit formulas for geometric and, arithmetic and geometric sequences. Okay. Now we all know that what a sub 1 is, and that's just your first term. And we know that the arithmetic sequence has a common difference. And it doesn't matter whether you have the recursive formula or the explicit formula. You have to have your a sub 1 and your common difference. Okay, notice those are both there. And if you have one formula and you want to create the other one, you just plug those terms wherever they need to go. Okay. The biggest thing, make sure you remember what a sub 1 is and how to find it, and make sure you understand what d is and how to find it. Okay, and then the differences on the different types of formulas is with the recursive, you have the formula to find a sub n would be whatever your previous term is plus the common difference. With your explicit formula, you don't have you don't have to worry about your previous term anymore. You just have your first term, your common difference, and then n minus 1 in parentheses. And we've spent lots of time figuring out how to find this information and how to distribute and simplify your equation. So we're not going to spend any more time on that in this video. Okay, and then let's look at the geometric sequences. Again, you have your a sub 1s. You just need to know where to put them and your common ratios and your previous term here. Okay, with the explicit formulas, you don't have a previous term. With recursive, you have to have you have to have just the previous term before you can find the next one. All right, so let's look at some example problems. You have the geometric sequence 3, 6, 12, and 24, and all we need to do is write the formula recursively and explicitly. Well, before we do that, we need to figure out what our first term is. Our first term is 3, and we need to figure out what our common ratio is. I know it's a common ratio because they tell us it's a geometric sequence right here. So again, with the ratios, you take the second term divided by the first term, and in this case, we could do 6 divided by 3, or 12 divided by 6, or 24 divided by 12. Either way, we're going to get a 2 for our common ratio. So now to write it explicitly, let's do that first since we've had lots of experience with that. So it's a sub n equals the first term, which is 3, times the common ratio, which is 2, and then raised to the power of n minus 1. Okay, super easy, right? Now for the recursive formula, you have to say that n sub 1 equals 3. You have to give us the first term. Okay, and then go ahead and give us the equation. So a sub n is equal to the previous term, a sub n minus 1 times the common ratio, which is 2. All right, let's make sure we have everything covered. The first term times the common ratio. Got it. Alrighty. So that was just one example for a geometric. Let's look at an arithmetic sequence. So now we have an arithmetic sequence. In this case, our a sub 1 is 25, and we have to find the common difference, d. Okay, 25 minus 22 is 3. So we're decreasing by 3, so that needs to be a negative 3. All right, so the explicit formula. A sub n equals my first term, which was 25, minus my common difference times n minus 1. Right? You should know how to simplify this. I will let you simplify it on your own to give yourself practice. Once you simplify it, you should get the formula negative 3n plus 22. Okay, or you might have gotten positive 22 minus 3n. Either way, that's what you should get. So go ahead and distribute the 3 combined like terms and see if you got either of those equations. All right, the recursive formula. So again, we have to say what a sub 1 is. Okay, in this case, it's 25. And then the rest of the equation would be a sub n equals the previous term, a sub n minus 1, and then minus the common difference of 3. Okay, pretty easy. Let's go back up, make sure we have it all set up. Okay, so usually it's a plus the common difference, but because we have a negative common difference, we're doing a minus 3. All right, let's look at this one. We have, again, we're writing the recursive formula and the explicit formula, but this time they do not tell us whether it's a arithmetic or geometric sequence. So let's try it out. So just looking at these two numbers, I want to say, let's add 80 to it. Okay. So if we're adding 80, we would have an arithmetic sequence. So let's check the second and the third term. If I add 80 again, I would get 480 plus 80 gives me 560. And you can see here that my third term is not 560. So guess what? It is not an arithmetic sequence. So because it's not arithmetic, let's go ahead and see if it's geometric. So 480 divided by 400. Let's see what that is. Okay. You can do this a couple ways. You can just reduce your fraction, or you can plug it into a calculator. And because we're in the video and thinking and talking and being recorded all at the same time is very disconcerting, so I'm just going to plug it into my calculator. I get 6/5. If I want to go ahead and convert that to a decimal, I can, and it's 1.2. So either way, 6/5 or 1.2. In this case, because it's not a repeating decimal, because it doesn't continue on forever, I will go ahead and let you convert it to a decimal. So this gives me the rate 1.2. Let's make sure that it is geometric and see if I take the next two terms, so 576 divided by 480, am I still going to get 1.2? Okay, let's check it out in the calculator. Whoops. Let's see, go. Okay, so 576 divided by 480, push, let's do Control Enter, and it gives me 1.2 again. So it does give me 1.2. This is my common ratio, so we're all good here. Let me go ahead and erase this so I have more space. So now I know my first term is 400. My common ratio is 1.2. So for the explicit formula, I'm going to have a sub n equals 400 times my common ratio, 1.2 raised to the n minus 1 power. Okay. Now for the recursive formula, let's write it over here. I'm going to say a sub 1 equals 400. Do not forget with the recursive formula, you have to include your term there, your a sub 1. Okay, so you have 400, and then so the regular equation would be a sub n equals my previous term, a sub n minus 1, times, trying to do a parentheses there. There we go. Times my common ratio of 1.2. Okay, so there's the two formulas.